Hi, good morning everyone. We are now going to be dealing with, this is the latest exam paper. It was set for April, but it was written in July because of the lockdown. Okay. Right, so let's go through this paper. This is like 2 days before the final exam. So now we're going to be going through it a little bit faster than usual. First question here deals with partial differentiation. So if you're given z is equal to ln of square root x plus square root y, prove that the square root of x times dz over dx plus the square root of y times dz over dy is equal to that. You double check the question here on the board, so you've got the paper on your phone. Right. So what do we know here? We know that if z is equal to ln f of x, then the derivative with respect to x, d over dx of z will be f prime x all divided by f of x. That we've been using from Pen 4. So that's exactly what we need to do here. But in this case, we are using partial differentiation. So I'm going to write down dz over dx. So if I write down my d using this symbol, that means I'm differentiating partially with respect to x. So if I'm differentiating with respect to this variable x, that means any other variable there will be treated as a constant, a number. Okay, so I got square root x plus square root y. So this is my function of x here. So f prime x, the derivative of square root of x will be half x to the power minus half plus, now this is not x, so anything that is not x you will treat it as a constant. The derivative of y is 0, all divided by whatever function you have there, which is square root x plus square root y. So that is my dz over dx. This can be simplified further. So remember that 1 over 2 times x to the power minus half is the same as 1 over 2 root x. If I take x to the denominator, the sign of the exponent will change. This is still in the denominator there. Square root x plus square root y. I'm not going to multiply this inside. I'm going to leave it as it is. Because if I look at the solution basically that we're given, there's only square root x plus square root y in the denominator. So let's leave it as it is and let's see what happens. So that's my dz over dx. Now dz over dy. So I go back using the same rule. I'm differentiating partially with respect to y. So I will treat any other variable as a constant. So the square root of x will be 0 plus the square root of y. That will be half y to the power minus half. So that will be f prime all divided by f, which is square root x plus square root y. Right, so nothing difficult there. So that will be 1 over 2 times the square root of y times square root x plus square root y. So this is our dz dx. This is dz over dy. So now let's go for the left hand side. So my left hand side is equal to square root x times dz over dx plus square root y times dz over dy. So that is square root x times my dz over dx. And what is my dz over dx? There it is 1 divided by 2 root x times square root x plus square root y. So this is my dz dx, and then I got plus square root y times dz over dy, which I just found there, which is 1 divided by 2 root y times square root x plus square root y. And now let's see what happens. Right, so let's see what happens. You can see clearly square root x and square root x will cancel there in term 1. So you end up with 1 over 2 times square root x plus square root y plus here you can see that square root y and square root y cancel. So you end up with 1 over 2 times square root x plus square root y. Now, what do you notice? The denominator is common. Right, if the denominator is common, how many times do you write down the denominator? You'll write it down once. So I've got 2, and then I have square root x plus square root y. And then what do? I will add the numerators up. You're clear with that? So 1 plus 1 will give me 2 on the top divided by 2 times square root x plus square root y. And now you can see that 2 and 2 cancel, so you end up with 1 over square root x plus square root y, which is equal to the right hand side. And that was the first one. Right, our next question, applications of partial differentiation. A very common question, specifically this one here, with the volume of a right cylinder, came out in many past exam papers. So the main thing is you need to know how to set up the problem. Okay, when I say set up, you're given the formula volume is equal to pi r squared h. Obviously we're going to be dealing with that. Let's have a look at the question. The radius r of a right circular cylinder increases, key word here is increases, from 4 to 4,1 centimeters. Okay, so what does that mean? It means your r was equal to 4 centimeters. Okay, that's what it was originally. Then it changed from 4 to 4,1. So delta r, that's a change, is actually 4,1 minus 4, the change in r. So let me just write that down. So that will be 4,1 minus 4, which is equal to 0,1 centimeters. Okay, and its height increases from 20 centimeters. So the original height was 20 centimeters, and the change in the height from 20 to 20,5, so that will be 20,5 minus 20, which is equal to 0,5. So we got all that information. Now we want to find the change in the volume. So there's volume, which is equal to pi times r squared times h. Pi is a constant, r and h are your two variables. So therefore you're going to have two fractions there in your formula. What do I mean? You will write down, let's write down the formula here. So delta V, so that is the change in the volume, is equal to dV dr times the change in r. So you differentiate partially with respect to a single variable, which is r, times the change in r, plus dV dh times the change in h. If you had another variable, like maybe k, I'll write down plus dV over dk times the change in k. So you count how many variables you have. Alright, so now let's find our dV dr. So we're going dV dr. So dv dr, so I'm differentiating with respect to r, so you will treat h as a constant. So therefore your h will be treated as a constant, so that's going to be 2 pi r times. Remember, h is a constant. Okay. So if h was a constant, that means it's just a number that could be in front. Okay. Now, so we got delta r plus dv dh. So here I am treating h as a, dv dh. So I'm differentiating with respect to h. I'm going to treat r as a constant. Okay, so that's going to be pi r squared times the derivative of your h there, which is 1. Okay, oh sorry, I forgot to write down the h. You have noticed that? Okay. Right, so now times delta h. Okay. So let me just go back. When you differentiate with respect to r, treat h as a constant. When you differentiate with respect to h, treat r as a constant. Okay. Now all we have to do is substitute these values and be done. So where are the values to substitute? So that's going to be 2 pi times r, which is 4 times your h, which is 20 times delta r, which is 0, 1 plus pi times r there, which is 4 squared times your delta h, which is 0, 5. Work that out on the calculator. What do we get? What do you get? Give it to me in terms of pi first. When you got the pi there. Well, let me the calculator there quickly. Sorry. So you get 24 pi. Is that correct? Let me do it. So it's 2 pi times 4 times 20 times 0, 1 plus pi times 4 squared times 0, 5, 24 pi's, correct? So you got 24 pi centimeters cubed, which is equal to 75,398 centimeter cubed. You all got that answer there? Right, so now we move on to question 2, integration. So first question involves, you can see, you should be familiar with it now. You have a fraction, there's a square, you have to complete the square. Okay. So now, let's write down completing the square. So let's take what we have in the denominator, which is x plus 3 all squared minus 8x. Now this is not in your standard form, so let's remove the brackets and see what happens. So if we remove the brackets here, it's going to equal to x plus 3 all squared, that will be x squared plus 6x plus 9 minus your 8x. Right, so here we have x squared, 6x minus 8x, that will give me minus 2x plus 9. Now, Completing the square, you make sure the coefficient of x squared is a positive one. That's sorted out. Next step is copy down term 1 and term 2. So that will be x squared minus 2x. Okay, now you will always put down plus half the coefficient of x squared minus half the coefficient of x squared, and then you have plus 9. Okay. So what is the coefficient of x? It's minus 2, and then you divide it by 2. Whatever the coefficient of x is, divide by 2. So that is minus 2 divided by 2. Do not forget to include the sign. Okay. That's x squared minus 2x plus minus 1 all squared minus 1 all squared plus 9. So what do? This is a standard, it's just a set method, it doesn't change. Once you got this, you count the first 3 terms and you factorize it in one step. You don't have to think too hard, it'll always be like this. So that's going to be x minus 1 all squared, and then we work this out. So this is going to be minus 1 squared, which is 1, so that's minus 1, 9 minus 1 is 8, so that's plus 8. Okay, so now let's transfer this to our problem. So now remember the integral of y dx, so you're going to put in your integration sign. You don't write down y now. When you're answering the problem, you will put in your integration sign. And what is y? Y is now 1 over, the denominator has been transformed. It is now x minus 1 all squared plus 8 and your dx there with respect to x. So now you go to your formula sheets, and you should be familiar 2 days before the exam. Very fast, you should be familiar on where to find this type. You should know there's a plus sign here. There's a fraction, there's no square root. So therefore, it's of the form 1 over a squared plus b squared x squared dx. There's a plus sign there, and this is equal to 1 over ab inverse tan bx over a plus c. So let's write it out. So this is 1 over, this is going to be the square root of 8 squared plus 1 squared times x minus 1 all squared. You will rewrite it so it matches this here. So your constant is a is root 8, b is 1, and x is x minus 1. So therefore, that's going to be 1 over ab. That's 1 over the square root of 8 times 1, a times b, and then we got inverse tan bx, so that's 1 times x minus 1 all over square root 8 plus c. Easy. This was 4 marks here. It's going to be 1 over root 8 times inverse tan x minus 1 over root 8 plus c. You can leave it like this here, it's fine. If you want to rationalize 1 over root 8, your calculator, okay, your calculator will not give you a denominator with a square root. So this is what your calculator does, it rationalizes it, right? Square root 8 times square root 8, so what happens? 1 times root 8 is root 8, square root 8 times square root 8 is 8, square root of 8 is the same as square root 4 times square root 2 all over 8. The square root of 4 is 2, so that's 2 root 2 over 8. So that becomes root 2, and 2 and 2 cancel. Root 2 over 4, correct? That's what your calculator gives you. It's fine if you replace 1 over root 8 with root 2 over 4. But it's unnecessary to do that. Okay, but it is okay. So that was the first one. Nothing. Alright, question 2.2. I doubt many people got this one correct, whoever wrote this exam. This one was a bit unusual. If I look at it for the past over 10 years, haven't seen a question where you have to simplify first a lot compared for this type of question. Okay, so here it's multiplication. That's ln 2x multiplied by ln x. Okay, so now this is only 4 marks. Okay, but now multiplication normally is integration by parts straight in the beginning. The problem is here, what are you going to let, what's going to be your f of x? Okay, you know your priority list for integration by parts. So, let's write it down, let's start. So we got the integral of ln 2x times ln x dx, multiplication. Alright, so what I'm going to do here is this 2x from our log laws. Okay, so from our log laws, if I have log of a times b, or whether it's ln of a times b, we know that multiplication will change to addition if the bases are the same. So this is the same as log a plus log b. So if it's natural log, then it's ln a plus ln b. So what I'm going to do here is, if you are wondering, there is no law for multiplying logs times log. A log times a log, there is no law. If you go back to n3, if I give you maybe log of 27 to the base 3 times log of, let me go for 1 over 9, 1 log of 3 to the base 9. This is multiplication. How would you do a problem like this? You will use the change of base law. Okay, because you cannot combine the logs. So if you want to do this, this will be log 27 divided by log 3, and that will be log 3 divided by log 9, and then log 3 and log 3 cancel. So 27 is the same as 3 cubed, 9 is the same as 3 squared, and then we can bring down our exponents there, which is 3 log 3 all over 2 log 3, and then log 3 and log 3 cancel, you end up with 3 over 2. Okay, I'm just refreshing your memory on some log laws. Here, what I'm going to do is, I am going to write the ln of 2x. I'm going to treat 2 as a and x as b there. So what's going to happen here, I'm going to write it as ln 2 plus ln x. Can you see the log law? Ln of 2x is the same as ln 2 plus ln x. Okay. Multiplied by ln x. Why am I doing this? Because now I have ln x similar to ln x here. Can you see that? So what am I going to do now? I'm going to remove these brackets. Okay. So this is going to, basically I'm going to multiply out. So that's going to be ln 2 times ln x plus ln x times ln x, which is ln x squared. So that's ln x times ln 2. Ln 2 is just a number. Then ln x times ln x, which is ln x all squared. Okay. So now these are two different problems here. Okay, so now I'm going to separate them into two. So that's going to be the integral of ln 2 ln x plus dx plus the integral of ln x all squared dx. Okay, so now we will use integration by parts. And we have, if you recall, when I was doing integration by parts, I did show you how to integrate ln x all squared, but we're going to do it now. Right, so integration by parts, you know with ln x, what do? You multiply by 1. So ln 2 is just a number. So we got ln x multiplied by 1, and you do the same here. This is going to be ln x all squared multiplied by 1. Okay. Now, Okay, so now here we got our ln 2 there. Now we have f of x, g of x minus the integral of g of x times f prime x dx. You should know that we're going to be using this here. This is 2 days before the exam. You should know what is your f of x here. I'm going to show you this now. And here, same thing. This is going to be f of x, g of x minus the integral of g of x times f prime x dx. Okay, now remember for the first one, my f of x is equal to ln x, so therefore f prime x is going to be 1 over x, and g of x now. Remember, this is f, this is g prime, so therefore g prime x is equal to 1. So if I want g of x, I need to integrate 1, which is going to give me x. So that takes care of this one here. Now what about this one? Okay. So let's deal with the second problem that we have there. My f of x now is going to be ln x all squared. Can you all see that? So then f prime x, this is going to be the chain rule. So the chain rule is you differentiate, that will be 2 ln x to the power 1. You deal with the power first, multiplied by the derivative of ln x, which is 1 over x. And we know that g prime x is also equal to 1. So g of x, you're going to integrate 1, which is equal to x plus c. Okay, you don't have to put down plus c, only in the final answer. Right. So let's do the substitution. So I have ln 2. Don't forget the ln 2 was always there. Alright, and then f of x is going to be ln x. G of x is x minus the integral of g of x, which is x. F prime x is 1 over x dx. So that is sorted here. Plus, let's do this part. Here, my f of x is ln x all squared. G of x is x minus the integral of g of x, which is x. And f prime x is 2 ln x times 1 over x dx. So that's using the second one. So now let's see what happens. So what do we have here? We have ln 2, and then I have ln x times x, which is x ln x minus the integral of x and x cancel, so you end up with just 1. Okay, here I got plus x times ln x all squared. What's going to happen here? X and x will cancel. I end up with just minus 2 times the integral of ln x dx. Alright, so now what do we need to integrate? To finish off this problem, all we need to do is integrate the 1 and then integrate ln x. Okay, now let's do this here. So that's going to be ln 2, and then I got x ln x minus integrate 1. It's going to be x. Okay with that? Okay, yeah. So what is this here? X ln x minus x is the result of integrating ln x. Are you clear with that? So therefore, there is no need now to go and redo the whole process here, because when you integrate ln x, the answer is x ln x minus x. So when you integrate ln x, you've already done it there. Okay, this is only 4 marks, so I don't expect you to go and show the whole thing again, because you've already shown working it. So this is going to be x ln x minus x. And now all integration has been done. You put down plus c. Okay, so now if you want to remove the brackets, you can. Up to you. Okay, so but the fact is, we've already integrated everything. Let me just remove it for you. So that's going to be ln 2 times x times ln x minus ln 2 times x plus x ln x squared minus 2x ln x, and then minus 2 times minus x is going to be plus 2x plus c. Okay, now that's basically it. You must know how to integrate ln x all squared and then ln x. So this was the problem that was unusual because of the beginning. This part here, the log. 2x is the same as ln 2 plus ln x. You are using your log multiplication, changes to addition. Why did we do that? Because I want ln x. This is ln x. Okay, if it was just ln x times ln x, then I would have went and multiplied ln x all squared in the beginning. The fact is, this was 2x, this was ln x, you could not multiply, they are different. Okay, so I split it up. That was that. Let's move on to the next one. Alright, our next one. So here we're dealing, we got tan squared, 1 plus tan squared, we got tan cubed. When you see squares, what must you remember? Square identities. Okay. Now, let's see how we're going to simplify this. So in the numerator, I know that 1 plus tan squared, straight, that is my square identity. Okay, let's put it in. First, we need to put in our integral there. So we're integrating 1 plus tan squared all divided by tan cubed. So 1 plus tan squared, that is your square identity. 1 plus tan squared is equal to sec squared, and then we all divided by tan cubed. Now, let's try and rewrite everything in terms of sine and cos. So sec squared is the same as 1 over cos squared, and then tan to the power 3 is the same as sine cubed divided by cos cubed. Right, tan is sine over cos, so tan to the power 3 is sine to the power 3 divided by cos. So now I have a fraction divided by a fraction, invert and multiply, so this becomes 1 over cos squared times cos cubed divided by sine cubed. Okay, so now let's see what happens here. Cos squared will cancel with cos squared, so you end up with just cos on the top divided by sine to the power 3. So this is a sine multiplied by cos problem. Okay, at the moment it's cos divided by sine, but you should have done many examples like this here before, and you should know that you must take sine to the top, so it becomes sine to the power negative 3 times cos. If you want to use a u substitution, you can now. This is exact derivative now. It's simplified, the derivative of sine is cos. So you go straight, and if you want to, you can let u equal to sine x, so du over dx. The derivative of sine is going to be cos, and then dx is going to equal to du over cos. Exact derivative, it's going to cancel, you can see that. So you got u to the power minus 3 you got cos x, and you got dx, which is going to be du divided by cos. So cos and cos will cancel. So you just end up with just u to the power minus 3 du. And now this is equal to minus 3 plus 1 is minus 2 over minus 2 plus c. You're done. Don't forget to substitute back for u. So that's going to be minus 1 over 2. My u was sine x to the power minus 2 plus c. It's fine. You should get full marks at this stage. But I'm just going to simplify it for you. This becomes 1 over sine squared. If you want to simplify to the max, then 1 over sine squared is equal to cos x squared. So at this stage, it was fine. At this stage here, but this is simplifying fully. Okay, so that was that. If you tried it out a different way, it's up to you. We're moving on to the next question. Alright, let's move quickly to the next one. So we need to integrate sine cube plus cos cube. Now, these are two different problems. They are separated by a plus sign. Sine cube plus cos cube. So let's separate them. So that's going to be sine cube x dx plus the integral of cos cube x. Separate them, and you know this one is just a method to remember. So what is the method here? If you have an odd power, you will split the odd power, use your square identity. So you're going to split it up, it's going to be sine squared times sine. You have an odd power, split it up, so that's going to be cos squared times cos. Okay, what do you do next? After you split up your odd power, use your square identity. So sine squared is the same as 1 minus cos squared, and cos squared is the same as 1 minus sine squared. So two different problems. So here, if you can use a substitution if you want to, or there is the method of inspection. Okay, but let me just do substitution for y'all. So in this case, you can let u equal to, let's call this u1, equal to cos x. In this case, you're going to let's call this u2 equal to sine x, because the derivative of cos is minus sine. It's going to cancel perfectly. The derivative of sine is cos. It's going to cancel. That's why we use our u substitution or inspection. So I let u1 equal to cos. So du over dx, the derivative of cos is minus sine. So dx is going to equal to du over minus sine. For that one, you can see it's going to cancel. Here, du over dx, the derivative of sine is cos, and dx is going to equal to du over cos. This one I think was the easiest from every single example that we've done so far. Okay, but I don't know why it's carrying the most amount of marks. Definitely easier than the rest here. So all you do is your substitution. If you are using substitution, so that's 1 minus u1 squared times sine x, and that is going to be du1 over minus sine x. I'm calling it u1 because I can't say this is u and that is u. You understand? There are two different u's. So let's call this u1. Let's call that u2. Here, that's going to be plus 1 minus u2 squared. That's cos x, and that's du2 over cos. You can see exact derivative example. I'm not going and explaining the whole exact derivative. You all know you can always check the other lessons of mine, which explains all this in detail. Okay, here we're just going straight for the answer. So you can see exact derivative will cancel. So here you end up with just 1 minus u1 squared du. And I forgot the negative, there's a negative here. There's a minus there. Here there is no negative, so that's plus 1 minus u2 squared du2. So it's all ready to integrate with respect to u. So that's going to be minus, integrate 1, that's u, and integrate u squared, that's u to the power 3 over 3. Are you clear with that? Here, that's going to be plus, integrate 1, that's u, integrate u squared, that's u to the power 3 over 3, plus c. And now, substitute that for u. What was u? This u1 was cos. So that's cos minus 1 over 3 cos x to the power 3. u2 is sin x minus 1 over 3 sin x to the power 3 plus c. There's no need to simplify. That's a very long paper. The N6 paper, most of the students never ever finish the whole paper. You have to be very fast to finish this paper. This is only 2.4. We've got a long way to go. Okay, let's move on to the next one. Alright, our last question from question 2. Okay, you can see, if you look at the time, how long did it take you to reach 2.5? So don't forget, you don't go and write down wider. You are integrating what you have here, so it will be 3 times inverse tan 1 over 3x dx. Now, with inverse trig functions, you know that it's integration by parts. Okay, when you're asked to integrate this inverse, and there's nothing else, there's no exact derivative here, so therefore it is going to be integration by parts. Okay, so what can you do? You already have the 3 there. Let's do it like this. Instead of writing down the 3 there, let's write down the 3 here. You follow? Normally we write down 1. Just like how I integrated lim x, I went lim x times 1. We need 2 factors. So we will use the factor that's given to us, which is 3. So what do? Priority lists. This is integration by parts. You should know. So now, f of x from your priority list is number 1, which is inverse tan of 1 over 3x. So therefore, g prime x will be whatever is there, which is 3. Now, f prime x, where did I do that inverse tan? Did I just do it somewhere now? Inverse tan. Oh, I didn't do it, sorry. Let me write it down. So, you go to your formula sheet. Oh, I remember we did it in under partial. Alright? It was a partial differentiation. It doesn't matter. There's a formula. So this is y is equal to inverse tan of f of x. So the derivative, you go to your formula sheets, the derivative of inverse tan is going to be f prime x all divided by 1 plus f of x all squared. That's your differentiation of your inverse trig functions. So how do you use the formula? F of x is 1 over 3x. Okay, so now my derivative f prime x, that means I need to differentiate. The derivative of 1 over 3x is going to be 1 over 3. All divided by 1 plus f of x, which is 1 over 3x all squared. Right. So this is the same as 1 over 3 divided by 1 plus 1 over 9x squared. Do we need to simplify any further here? Let's see as the problem goes along. Okay, so now g prime x is equal to 3. So g of x, you're going to integrate 3 with respect to x, which is going to be 3x. And now we will substitute into the formula. Perfect. So now what is the formula? Well, let's write it down properly. So therefore, so let's do it right here. So therefore, the integral of inverse tan of 1 over 3x times 3. The formula integration by parts is f of x, g of x minus the integral of g of x times f prime x. You should know these formulas, otherwise it's going to slow you down. Okay, it's best to know most of the formulas, especially when you reach N6. Formula sheets, yes, if you're familiar with it, if you know exactly where to find it, then it's okay. But the best thing is to have it in your head. Right. So now, f of x, what is my f of x? Inverse tan 1 over 3x. G of x, which we just worked out here, is 3x minus the integral of g of x, which is 3x, and then f prime x, which we just found there, that's 1 over 3, all divided by 1 plus 1 over 9 x squared dx. Okay, so what am I thinking now when I look at this problem as it is? You check, there's an x squared there in the denominator. You're looking for x in the numerator. If you do have an x there, you know it's going to be easy. This is an exact derivative problem. Clearly, there's an x there. So let's remove all the constants first. So that's going to be 3x times inverse tan of 1 over 3x. Here, 3 and 1 over 3 will give me just 1. So that's x on the top and 1 plus 1 over 9 x squared in the bottom. Alright, 3 and 3 cancel. Here, you can see that. So what are we dealing with here? We are dealing with this problem here. F prime x on the top, f of x in the bottom, where the answer is always ln absolute value of the denominator plus c. That's exactly, you must recognize these types. So you can use a u substitution. You can let u equal to 1 plus 1 over 9 x squared. You always let u equal to f of x when it's type A, B, C, and D. Those are the exact derivative problems. So here, du over dx. The derivative of 1 is 0. The derivative here will be 2 over 9x. And then you make dx the subject of the formula. Let's see what happens. You should know what happens. X and x must cancel. So you end up with 3x times inverse tan 1 over 3x minus 1. I got x on the top, and my denominator there is u, and dx is no more dx, it's du divided by 2 over 9 times x. Right, all this unnecessary if you know the method of inspection, but the majority of students do not know the method of inspection, so therefore we will be using u substitution. You can see that x and x will cancel, so I end up with 3x times inverse tan 1 over 3x minus 9 over 2, and that becomes 1 over u du. Okay. So that's going to be 3x times inverse tan 1 over 3x minus 9 over 2 integrated 1 over u, that's ln absolute value of u plus c, and you're done. Don't forget to substitute back for u. So that's 3x inverse tan 1 over 3x minus 9 over 2 ln absolute value of the denominator. What was my denominator? 1 plus 1 over 9 x squared. Alright, so remember when you simplify, Here, this is a fraction below the denominator. If you don't know, Google it. Okay. You should know by now. Right, question 3.1 and 3.2, similar to chapter 3 in your textbook, we are dealing with partial fractions. Okay, so we need to integrate everything here with respect to x. They should have had a bracket, because the dx is like only next to term 2, then you've got to integrate. It should be in brackets. This is a proper way to write it down. Okay, now, but it was not in the final exam. So, basically, these are two different problems here. This is not partial fractions. All you're going to do is integrate x. It will be x squared over 2. That's done. Forget about that for now. This is the focus is on this part here. Now, this looks like the result of a long division problem. Normally, you're given a long division problem, you divide and then you get the quotient plus the remainder all over the denominator, if you go back to any other paper. Okay, so it seems like they did the long division for you and just put it here now and see what do you do after this here. Right, so the focus is on this part. So yeah, so let's write down 5 minus 5x all divided by 6x squared plus x minus 1. Factorize. And this is definitely a proper fraction. The numerator is of a lower degree than the denominator. What do I mean? The highest power here is 1. 1 is smaller than the highest power there, which is 2. So therefore, this is a proper fraction. Let's factorize this here. So let's go for 3x and 2x. Let's try it out. Okay. So if I put a plus 1 there and a minus 1 there, I'm just trying out my luck and then I'm going to check the middle term. So I'm going 3x times 1 is 3x. Minus 1 times 2 is minus 2x. So 3x minus 2x is 1x. That's correct. Negative times positive is negative. That's correct. These are the factors. You can say that. Right. So now, this is an easy one. 3.1. It looks like they killed you in question 2 and they said, okay, let's give them something easy now. In question 3 to get back in action. Okay. That's what happens in the exam. Certain questions will be tough and then certain ones will be okay. Like this one, definitely an easy example compared to other one, compared to the next one that we're going to do. So this is going to be a all over 3x minus 1 plus b all over 2x plus. So this is like an N5 type problem. You never ever find a and b only. Only A and B and N6. Normally you have A, B, C, D. But that is the next one. So what do we do? You should know now. I'm not going to do all steps. You're going to multiply by the factorized denominator on the left hand side and on the right hand side. So this will cancel. So you end up with 5 minus 5x is equal to A. 3 minus x will cancel with the 3 minus x. 3x minus 1 will cancel with 3x minus 1. And you end up with 2x plus 1. 2x plus 1 will cancel with the 2x plus 1, which has been multiplied, but you know, I'm not showing you every single step now, you know. 2x plus 1 will cancel with 2x plus 1, so you end up with 3x minus 1. Okay, what do we do now? Solve for a and b. This one clearly can be done by substitution. There's no need to multiply the whole thing out. So here, 2x plus 1, what can I substitute that will result in 2x plus 1 becoming a 0? At N6 level, you should know that in half a second, not even 1 second, half a second, you should tell me the answer. What are you going to substitute here? Minus 1 over 2. Okay, so you're going to substitute minus 1 over 2, and then you will get your solution. So that's going to be 5 minus 5 times minus 1 over 2 is equal to A times 0 plus B, and that's 3 times minus 1 over 2 minus 1. I'm not showing you the substitution here because why did you let x equal to minus 1 over 2 in the first place? Because you wanted 2x plus 1 to become 0. That is the whole idea. Okay. So this is 5 plus 5 over 2, so that's going to be 15 over 2 there, correct? Here, that's going to be minus 3 over 2 minus 2 over 2. That will be minus 5 over 2. B. So therefore, B is going to equal to negative 3. You got that? Okay, you double check me on the calculator. Let me move to the next one. Alright, so let x equal to. Now the focus is on 3x minus 1. What will I let x equal to now? This is going to be 1 over 3. You can't be so slow 2 days before the exam. You must be faster. Okay. So let x equal to 1 over 3. Go back. And this is going to be 5 minus 5 times 1 over 3 is equal to a, and that's 2 times x, which is 1 over 3 plus 1 plus b times 0, because 3 times 1 over 3 is 1 and 1 minus 1 is 0. That was the whole idea. Let's work this out. So here we got 15 minus 5 again, which is 10 over 3, yeah? Correct? And then here we got 2 over 3 plus 3 over 3, which is 5 over 3a. So therefore, a is equal to 2. You got that? Right, so now let's do the substitute bracket. So therefore, the integral, now don't forget, it's x plus 5 minus 5x all over 6x squared plus x plus 1. This was the original question that was given to us. And now, it is now equal to the integral of x with respect to x. We don't forget about the x. And now let's deal with this part. Plus, this is now a over 3x minus 1, which is 2 over 3x minus 1 dx plus b. So that's going to be plus, what is my b? Minus 3 all over 2x plus 1 with respect to x. Now, I'm not going to use substitution. I'm going to use inspection, but it's up to you. This is the same type as the one we just did previously when we integrated ln there. When we used ln. It's the same type. It's a fraction where the numerator is an exact derivative of the denominator. Okay, so I'm going to use the method of inspection. So this is how I'm going to do it. I'm going to take whatever constant I have here and write it in front, and that becomes a 1. I'll take whatever constant I have there, write it in front, and that becomes a 1. You see that? So, now integrate x to the power 1, so that will be 2 over 2. Here, the method of inspection. The derivative of 3x is 3, so I'll multiply by 1 over 3 there to cancel the 3. The derivative of 2x is 2, so I'll multiply by 1 over 2 to cancel that 2. If you don't know by now, don't try this. It's best to use substitution. Okay, this method has to be mastered way before, right, like in N5. So the safe way to do it, let u equal to 3x minus 1, fine, it's going to work out perfectly. Here you do, let u equal to 2x plus 1. So by inspection, this is going to be 2 over 3, ln absolute value of 3x minus 1. And here this is going to be minus 3 over 2, ln absolute value of 2x plus 1 plus c, and you're done. Let's move on to the next one. This one was 5 marks. Right, the next one, 3.2, 7 marks. Partial fractions. So check the degree of the numerator, that's 3. Degree of the denominator, that's 2 plus 1, which is 3, plus 1, which is 4, because if I multiply x squared times x, it's going to be x to the power 4. So therefore, the degree of the denominator is 4, numerator is 3, 3 is smaller than 4, so therefore it's fine. We go straight and use partial fractions. The only time we do not use partial fractions if the degree is if the numerator is not smaller. If it's equal or higher, then you must use long division first. Okay. Now, degree of the denominator again, x to the power 1 times x to the power 1. Forget about the rest, not important. X times x squared is x to the power 4. So you know you're going to have A, B, C, D, 4 constants here. So let's write that down. So I got 2x cubed plus 6x squared minus 12 all divided by x times x plus 3 times x squared plus 3x plus 4 is equal to. Okay, now let's write down our fractions. So that's going to be A all over x plus B all over x plus 3. And now we have this quadratic here of x squared plus 3x plus 4. We must make sure that this cannot be factorized. Okay, if it can be factorized, then it's going to be easy. Let's see, this is a 4. 2 times 2 is 4. 2 plus 2 is 4. I'll never get 3 there. 4 times 1 is 4. 4 plus 1 is 5. This is not a 5. This is not a 2. This cannot be factorized. So therefore, you're going to write down cx plus d. Or if you wanted to, you start with ax plus b. You know, it's up to you. As long as you make sure you've got the x here, you've got a constant there, plus another constant. Right, now, what do we do? So let's get rid of all the denominators. That's in one step also. So that's 2x cubed plus 6x squared minus 12 is equal to a, x will cancel with x, so you end up with x plus 3 times x squared plus 3x plus 4. Then you got plus b, x plus 3 will cancel with x plus 3, so you got x times x squared plus 3x plus 4. And then you got plus cx plus d, and then x squared plus 3x plus 4 will cancel. This is a shortcut method. This is how you should do it in the exam. You've got no time to go and write down, you know, all the multiplication there. You should be able to at this stage, just like how I'm doing it now. You should be able to do it. So this is x times x plus 3. Now, what method should we use? We can use both methods. If we use the substitution method, you have to stop and think, before you go further with this here. Now, what will you be able to work out? Now, the whole idea is to work out A, B, C, and D. I can let x equal to minus 3. So that's 0. That's 0. I'm going to work out B. One time. Okay. I can let x equal to 0 also. So that will be 0, that will be 0, and then I'll work out A. And after that, I am stuck. I won't be able to work out anything. I will be forced to use simultaneous equations. You can do it that way if you want to. Okay. The other way would be to multiply this whole thing out here and use the method of equating coefficients. Okay. You should know which method you are faster with. Okay.
Which one is easier, sir?
Hey, both, you're going to see, like this example, you might want to use both. It all depends on the example. Both are easy, the other one just takes longer because you have to make sure when you're removing the brackets. Okay, then let me show you equating coefficients while we're on this here. So what is equating coefficients? It's going to take long, I'm going to multiply this whole thing out here. Let's try that. Okay, so if you say it's taking too long, then we can always switch back and use a substitution because we always got line 1 written down here. We can always go back and find what we need to find. Let me show you all equating coefficients now. Remove the brackets. X times x, so what am I going to do? Multiply x times there, and then 3 times, 1, 2, 3 there, and I'm done. Yes. I have to do it there. Oh, here too is another problem there, but anyway, that's going to be x to the power 3 plus 3x squared plus 4x plus 3x squared plus 3 times 3 is 9x plus 3 times 4 is 12. I can just see this thing is going to take long. But anyway, let me multiply here. So that's going to be bx times x squared is bx to the power 3. Bx times 3x is going to be plus 3bx squared. And bx times 4 is 4bx. Now, here, so x times x plus 3. So you got cx plus d times x squared plus 3x. That's what you have here. Can you see that? X squared plus 3x. So if I go cx times x squared, that's going to be plus cx to the power 3. Cx times 3x is plus 3 cx squared plus dx squared plus 3 dx. So far, there's nothing difficult that I've done. It just is time consuming to go and multiply this whole thing out. So what else do we need to multiply? It's just this part here. Okay. So what's going to happen now? I'm going to have the a's all here. Okay, I'm going to have the a's there. So let me just put in the a's while I'm here instead of writing it down again. So that's ax cubed. This is going to be plus 3ax squared. This is going to be plus 4ax. This is going to be plus 3ax squared. That's going to be plus 9a and then plus 12a because the a had to be distributed to everyone. Alright. So then the brackets are now removed. Okay, I can do this because I'm working on the board. Easy for me to rub out. Alright, so now let's start equating and let's start grouping. So you start with the highest power there. The highest power is 3. So take out x to the power 3 and let's write down everything there. What do we have? A plus b. I'm looking for all the x to the power 3's plus c. That's all. Correct. A plus b plus c. Now I deal with x squares. So then I have 3a plus 3a again. That's 3a plus 3a plus 3b plus 3c plus d. Yeah, doesn't look too good here, but anyway, let's see what happens. Plus, let's deal with the x's now. Look for all the x's. We're starting with 4a plus 9a. Am I right? Just double check me there. That's 4a plus the next one with x is 9a. And the next one with x is plus 4b. And the next one with x is plus 3d. I don't think this method here, if you are writing the exam, it takes a bit too long. Alright, but anyway, let's continue since we already started. Constants, anything that does not have x. What? Can you see anything that does not have x? This has an x, an x, an x, an x, an x, an x, an x. This is the only one. Can you see that? It's plus 12a. Yeah. Taking too long. I can just see that this technique. But anyway, let's do it. So that's 2x cubed plus 6x squared minus 12. So let's start equating coefficients now. Right, so on the left hand side, I got 2, which is the coefficient of x to the power 3. On the right hand side, I have a plus b plus c. Right, let's move on to the x squares now. On the left hand side, I got 6. On the right hand side, I have, what is it, 3a plus 3a, which is 6a plus 3b plus 3c plus d. What about x now? On the left hand side, there's nothing, there is no x there. So it's actually 0x. On the right hand side, I have 9 plus 4, which is 13a plus 4b plus 3d On the left hand side, constant is minus 12. Must equal to the constant on the right hand side, which is 12. And finally, I have something, but it's not good enough. It's only one constant here. Minus 12 divided by 12 is equal to A. So A is equal to minus 1. Okay. Now, let's see what we can do here. Okay. Let's see my A, and then I got B and C there. I can work with this there, but not advisable to go and start working out simultaneous equation. But let's do it. What do we know? That 2 is equal to A. What is A? Minus 1 plus B plus C. So 2 plus 1 is 3 is equal to B plus C. You see that? Now, what am I going to do here? Okay, so if I divide this whole thing here by 3, okay, or let me not divide it, let me just show you something. If I got 6 is equal to 6 times A, which I already know the value of A, watch it out. If I go plus 3, and then I got B plus C, and then I got plus D. I took out 3 as a common factor there. Can you see that? Watch it. So, what is A? It's minus 1. Okay, so now I got 6 is equal to minus 6 plus 3, B plus C plus D, and B plus C is 3. Can you see where I got that from? Because remember, B plus C is equal to 3. So I replace B plus C with 3, and now I can work out the value of D. So what is D going to equal to? 3 times 3 is 9. 9 minus 6 is 3. Take 3 to the left. Minus 3. 6 minus 3 is 3. So 3 is equal to D. Now double check me on the calculator there. So I got A, and then I got D. Okay, I got A, I got D, and I still need to work out B plus C. So now I can see this thing is going to take too long. I'm going to go and use inspection to work out the rest. Okay, but for those of you who are watching, you can see this is the method of equating coefficients. Right. We can go and continue and work out simultaneous equations, but you must have more than one option to work out the problem. You can't have only one method. If one method takes too long, switch to the next. Now what am I doing now? I'm going to switch back to the step n. Because this is the easiest thing to do. Let's see what we can find. Let's go straight. There's x plus 3 there. Okay, so what must I do? Let x equal to minus 3. Okay, so if I let x equal to minus 3, give me the calculator. So then I will substitute minus 3 on the left hand side there. And then I get minus 12 on the left hand side. So what do I get here? 0. What do I get here? 0. So now I can work out the value of B. Okay, so I got minus 12. That's 0. So I know 0 is the first one. This is the one I need to work out. Okay, so that's going to be, let's substitute there. What are we substituting? Minus 3. And so when I substitute minus 3 here, I get minus 12. So this is going to be minus 12b. Can you see how fast this is? How easy it is? Just by substituting, we get our answer there. So minus 12 divided by minus 12, b is equal to 1. Okay. And what else do we need now? We got A, we got B, we got D. I don't need to go and use substitution again. Let me go straight to this one. Remember this one here? 3 is equal to B plus C. So 3 is equal to B plus C. So 3 is equal to 1 plus C. So C is equal to 3 minus 1, which is 2. Okay. So what have I done here now? I have used both methods. When I saw that this one is I worked out something here, but then I realized no, it's gonna, if I continue doing this, I'm gonna take too long. We don't have time. It's 3 hours in the exam. You understand that? So I realized that hey, let's go back, use a substitution. You can't go wrong. You got your calculator unless you don't know how to use a calculator properly. Right, so we get your solution, let's substitute. Right, so therefore we have the integral of a over x. What is my a? Minus 1. That is minus 1 over x plus the integral of b all over x plus 3, which is going to be, where is my b? Did I not work out b? We got a. Oh, sorry, there's b there. B is right here. I mean, underline. It's best to underline so I don't make a mistake. That's my a, b, c, d. Right. So that is 1 over x plus 3 and cx. Where is my c? C is 2. So that's plus 2x. And what is d? d is 3. So that's plus 3 all over x squared plus 3x plus 4 dx. And this one seems to be perfect here. Can you see that? It seems to be perfect because the derivative of x squared is 2x. The derivative of 3x is 3. It seems like this is perfect. Let's carry on. So here, you should know this is type B. The numerator is a derivative of the denominator, so that's going to be minus 1 ln absolute value of x plus 1 ln absolute value of x plus 3 plus ln absolute value of x squared plus 3x plus 4 plus 6, and we're done. So that was our partial fractions. Right, so now we move on to differential equations. First order linear differential equation. Now, standard form here. We know that dy over dx plus p times y is equal to q, and then your integrating factor is equal to e to the integral of p dx. That is your standard form. Okay, but now here you're given dx over dy, not dy over dx. I don't think the examiner made a mistake over there. So one option is to manipulate this whole thing. Manipulate the whole thing and try and get it as dy over dx, or you can do it as it is. Okay. Imagine that you have like maybe dr over dt or something. Okay. But let's say if you wanted now to manipulate this equation and write it as dy over dx. Okay, how would you do that? So if I want to manipulate this equation here, so dx over dy will equal to 2x plus 3y. Okay. Now, if I have to go and invert the left-hand side, it becomes dy over dx. Remember, this is all over 1 on the right-hand side. Can you see that? So if I have to swap numerator and denominator of the left-hand side, that means I have to swap numerator and denominator of the right-hand side, which is going to be 1 over 2x plus 3y. Okay, so it does not help us in this way here. Because now, if I want to rearrange it in this form over here, dy over dx plus p times y is equal to q. If I go and cross multiply now, let me just show you what will happen. So if I go dy over dx, and then if I cross multiply, it's going to be 2x plus 3y is equal to 1. Right, and if I have to remove the brackets now, I won't be able to separate this properly. Okay, so if I multiply here, I'm going to have dy over dx. See, the problem is dy over dx has to be distributed to both terms here. So I won't be able to have dy over dx alone. Okay, so what do we do? Okay, so you deal with it as it is. Okay, as it is, it's just that now what you can do is, now let's say you are used to this standard formula. Okay, that's what you are used to. You are used to this standard form of dy over dx. So what you can do is replace x with y and replace y with x. Work with it and then replace it back at the end. You can do that. Okay. So what I want to do is, I will say, let x equal to y. Okay. So what I want to do is, I want to write this as dy over dx. Okay. So what I'm doing is I'm replacing x with y because I want to write it in that form then. So x is y is x. I'll go dy over dx minus 3x is equal to 2y. Okay. So now I can go dy over dx minus 2y is equal to 3x. Okay. So now my standard form, there's a standard form now. Can you see that? So dy over dx plus p times y is equal to q. So let me just write that down. Dy over dx plus minus 2 times y is equal to 3x. So then your integrating factor is equal to e to the power integral of p dx. That's going to be e to the integral of minus 2 dx. Right. So this is going to equal to e to the power minus 2x. Now, what do we do after this? We're going to go y times your integrating factor is equal to the integral of q times your integrating factor dx. So it's going to be y times your integrating factor there, e to the power minus 2x is equal to q. Q is the right hand side. Remember, this here is p. There's your p times y. And the right hand side here is q. So that's a q. So that's going to equal to e to the power minus 2x times your q there, which is 3x. And this is integration by parts. Okay, there's a lot of integration by parts here. Can you see that? Why? Because the derivative of minus 2x is not going to cancel here. There's an x here. If there was no x here, then it's straightforward. Okay, but the fact is you got x there. This is going to be integration by parts, which is f of x, g of x minus the integral of g of x times f prime x dx. And then, what is my f of x? Remember from your priority list, f of x will be 3x. So f prime x is equal to 3. G prime x is going to equal to e to the power minus 2x. So to get g of x, you need to integrate e to the power minus 2x, which is going to be e to the power minus 2x over minus 2. So what is my f of x here? It is 3x. G of x is e to the power minus 3x all over e to the power minus 2x all over minus 2 minus the integral of g of x again, e to the power minus 2x over minus 2. F prime x is 3 dx. All I have to do is just integrate this part here, so that's going to be minus 3x over 2 e to the power minus 2x. Negative and negative will give me a positive 3 over 2. The integral of e to the power minus 2x dx. And now all I have to do is just integrate this part here. That is minus 3 over 2x e to the power minus 2x plus 3 over 2. Integrate e to the power minus 2x. It's e to the power minus 2x over minus 2 plus c. On the left hand side, I got y e to the power minus 2x. So at the moment, this is your general solution. Okay, is your general solution. Now, remember in the beginning, I said let x equal to y. Okay, now let's substitute back. Right, let's substitute back because now we've got our general solution. So why did I do this here? Because it was given to me in the form dx over dy. And we wanted to work with it as dy over dx because we're used to it. Right, so what I did was I swapped x and y. Now I need to swap it back. Right, so this is going to be x e to the power minus 2y is equal to minus 3 over 2y e to the power minus 2y minus 3 over 4 e to the power minus 2y plus c. Right, so we swap it back and now let's do our substitution. Let's say when x is equal to 1, y is equal to 0. That is the particular solution. So at 1, 0. Okay, so what does that mean now? That means now I went back in order now. So that means 1 is x and 0 is y, as it was given to me. So whenever I see x, I'm going to put 1, so that's 1 e to the power minus 2 times 0. And I got minus 3 over 2. 0 there, 0 there. Minus 3 over 4 e to the power minus 2 times 0. Plus c. So wherever we have an exponent of 0, we know e to the power 0 is 1. So here we know e to the power 0, that's a 1 there. So let me just write this down properly. Right, so let's see, where are we now? So on the left hand side, I have 1. On the right hand side, 0 there, and that's going to be minus 3 over 4. Plus c. So therefore 4 over 4 plus 3 over 4 plus 3 is 7 over 4. So c is equal to 7 over 4. Just double check there. I don't think there's any mistake there. Minus 3 over 2, minus 3 over 4 there. So therefore, x e to the power minus 2y is equal to minus 3 over 2 y e to the power minus 2y minus 3 over 4 e to the power minus 2y plus 7 over 4. And that is the particular solution. Right, for question 4.2, second order differential equation. Second order linear differential equation. So, what do? We solve it. There's two parts to the solution. Okay. So to get your general solution, you need to find the complementary function first and then the particular integral. So, part one is forming the complementary function, forming your quadratic. So what you do here is you're going to let y equal to 1, d over dx equal to a letter which the textbook always uses m. You can use r also if you want to, up to you. And if I square this, it becomes d squared or d over dx squared is going to equal to m squared. And then the right hand side, you replace the right hand side with 0 always. Okay. So now what's going to happen here is you have m squared minus 6m plus 9 equals to 0. Remember, y is 1. 1 times 9 is 9. Okay, now factorize. So that's going to be m minus 3. M minus 3. Right, so m1 is equal to m2, which is equal to 3. Okay, m1 is equal to m2, which is equal to 3. So these are called real and equal roots. Real and equal roots. Okay. So you will go to page 7 of your formula sheet and you should be familiar with real and equal roots. This is the formula. YCF is equal to A e to the power m1x plus bx e to the power m1x. It doesn't matter whether you call it m1 or m2 because m1 is equal to m2. Okay, so this is equal to A e to the power 3x plus bx e to the power 3x, and that's part 1 sorted in 1 minute. Let's see that. All you have to do is form a quadratic, factorize, find the nature of the roots and choose the correct formula. Now part 2 of the solution. So now we're going to go for finding the complementary function YCF. Okay. We're going to find the complementary function. Okay, so the focus now is on the right hand side of the original equation. The right hand side is exponential. So let's write that down. The right hand side is an exponential function. So if it's an exponential function, then you're going to let y pi, which is particular integral, equal to c times this. You don't have to include the 18 there, or any number that's there. So it's going to be c times e to the power minus 3x. Okay, if you want to put 18, then you write down 18c. But you see that it will come to the same answer whether you have it or you don't. Okay, so check. Once you write this down, you check if this minus 3x, if you don't have e to the power minus 3x. If you have e to the power minus 3x, then you must change this and you put it as cx e to the power minus 3x. But if this is also x e to the power minus 3x, and that is also x to the power minus x times e to the power minus 3x, and you multiply by x again. Right, but it's not the case. This is a minus 3x plus, it is not the same, so therefore we continue. First derivative, dy over dx. The derivative here is going to be minus 3c e to the power minus 3x. Second derivative, d squared y over dx squared will be 9c e to the power minus 3x. You all know how I got the 9. Differentiate the minus 3 again. What do you do now? Substitute into the original equation. So you're going to sub into the original. Where is the original? Let's write it down. D squared y over dx squared minus 6 dy over dx plus 9y is equal to 18 e to the power minus 3x. So what is the second derivative? It is 9c e to the power minus 3x. And then we got minus 6 times the first derivative there, which is minus 3c e to the power minus 3x plus 9 times y. What is y? It's c e to the power minus 3x is equal to 18 e to the power minus 3x. Alright, we need to find the value of c now. So therefore we got 9c e to the power minus 3x. Negative and negative is a positive 18c e to the power minus 3x plus 9c e to the power minus 3x is equal to 18 e to the power minus 3x. So these are all like terms, we can add them up. So we got 9, they are all the same. So 9 plus 9 is 18 plus 18 again, 36. C e to the power minus 3x is equal to 18 e to the power minus 3x. Equating coefficients. 36c is equal to 18. So c is equal to 18 over 36. So we got c is equal to half. So therefore, ypi is equal to half e to the power minus 3x. Go back and substitute it. Remember, c is what we were looking for. Now, your general solution is made up of ycf plus ypi. ycf was, where is ycf? It was a e to the power 3x plus bx e to the power 3x plus ypi. So that's plus half e to the power minus 3x. Now, this is not the end. They say find the particular solution. Okay, so find the particular, that means we have values to substitute. So what do we know? Y is equal to 1 when x is equal to 0. Let's do the substitution here. So y is equal to 1 when x is equal to 0. So that's going to be a e to the power 3 times x plus b times x e to the power 3 times x plus half e to the power minus 3 times x. So what is x? x is 0. And here too, 0. So let's work it out. So now 1 is equal to a plus half. So therefore a is equal to half. So we found the value of a. Now we need to find the value of b also. Alright, so now what do we know? When dy over dx is equal to 2, but there's no dy over dx, it's just y. Can you see that? Remember, what is y? Y is equal to a e to the power 3x plus b x e to the power 3x plus half e to the power minus 3x. So that is y. Now we need dy. This is dy over dx. So what is dy over dx equal to? We will have to differentiate it first. I told you, most of 95% of the students will never finish. Only the very fast people. You must be able to write fast. Every single thing here is long. You can see. You thought partial fractions was long. This is also long too. The second one, you can see that. Wait till we move to chapter 5. Right, so the derivative here of a e to the power 3x is 3a to e to the power 3x. The derivative here is the product rule because it's bx times e to the power 3x. So you write down the first term, which is bx, differentiate the second, 3e to the power 3x, plus write down the second term, e to the power 3x, differentiate bx, which is b. Differentiate this, that's going to be minus 3 over 2 e to the power minus 3x. Okay, this is a b here. Looks like an 8. That's b. Product rule. Okay, why is it the product rule? Because you are multiplying bx, you're multiplying an x by e to the power 3x. Multiplication, product rule. Right. So now it's ready for substitution. Dy over dx is equal to 2 when x is equal to 0. So 2, 3a e to the power 3 times x plus b times z times 3 e to the power 3 times 0 plus b e to the power 3 times 0 minus 3 over 2 e to the power minus 3 times 0. So wherever we see x, we are replacing it with 0. Easy when you're substituting 0 in an exponential function. You don't need a calculator. So that's going to be 2 is equal to 3a plus b minus 3 over 2. And we already know what the value of a is. So 2 is equal to 3 times a plus b minus 3 over 2. And my a is half. So therefore, let's see what we have here. Okay, so I've got 3 over 2 minus 3 over 2. So b is equal to 2 straight. Because I got 3 over 2 and minus 3 over 2, which will cancel there. So b is equal to 2. So therefore, the particular solution now y is equal to half e to the power 3x plus 2x e to the power 3x plus half e to the power minus 3x. And that is the particular solution. And that is question 4. How long did we take? How long did I take? 1 hour 45 minutes here already. Alright, so now we move on to the more difficult stuff from question 5 onwards. Applications of integration. Alright, so let's go straight on to this one here. So sketch the graphs. 5.1.1 of y is equal to 2 ln x. Common graph. Okay, you should be familiar. It came out in many exams. Ln x. Okay. Y is equal to 2x. Show the area bounded by the graphs and the x-axis, and the line y is equal to 2. Show the representative strip that you will use to calculate the area. Alright, so this is your log graph, a natural log. Okay, you should be familiar with it. So let's sketch it. Only 2 marks, so you don't have to go and show about 5 or 6 coordinates here and draw a table. You must be familiar with the shape. Okay, so your log graph, y is equal to 2 ln x. Okay, this is how it's going to look. The log graph is the inverse of the exponential graph. If it was exponential graph, then it's going to cut the y-axis. For your log graph, it's going to cut the x-axis. That's how you remember. Exponential graph will have a y-intercept. Your log graph will have an x-intercept. So if I want to work out the x-intercept, I will let y equal to 0. Okay. So what do I have here? Y is equal to 2 ln x. So if I replace y with 0, so 0 is equal to 2 ln x. 0 divided by 2 is equal to ln x. That means ln x is equal to 0, because 0 divided by any number is 0. So from your log laws, if log a to the base b is equal to c, this is a log equation. You convert from log form to exponential form. So a is equal to, the base of the log becomes the base of your new exponential equation. Okay. So if the base is not shown, for natural log it's e. For log it's 10. Okay, be careful. So therefore x is equal to e to the power 0, which is 1. So that's 1. Okay, let's write it down properly. 1, 0. On the x-axis, y is equal to 0. Right. Now, we got this graph. The line y is equal to 2x. Okay. The line y is equal to 2x. Now, we need to check if these two are intersecting, but let's just see how are they going to intersect. If I'm sketching y is equal to 2x, I need to see, is it going to be looking like this here? Or, okay, we need to check this. Or, is it going to be looking something like that? Because I'm doing a rough sketch now. You follow? Because I'm doing a rough sketch now, I need to make sure now, because it'll change everything if the sketch looks like this here. Okay, so now let's test out a few values here. Okay, you can find out if these graphs intersect, but what else do we need to sketch here? The line y is equal to 2. So the line y is equal to 2, somewhere around here. Here is the line y is equal to 2. Okay. Now, we need to determine whether these two graphs are, are they touching or not. Now we can do that by finding out if there's any points of intersection. Okay. Or we can use a table to check. Okay. So let's do a comparison here quickly, just to make sure before we move on. Okay, so let's use a table. So I got x and I got y is equal to 2 ln x and I also have y is equal to 2x. Now let's make use of that table function on our calculator. Let's take a few values. Okay, let's go for 0, let's go 1, 2, 3, 4, 5, 6. And let's see the corresponding y values here that we have. Just to make sure. Give me the calculator. Right, so I want to make sure now that that's the picture, or is it this the picture, or is this is these graph, are these two graphs intersecting? I'm talking about the line y is equal to 2x, so I'm going table. Most of the calculators will be number 3, but if you're using this one, it's number 7. It asks you for f of x. This is going to be my f of x, which is 2 ln, you go alpha close brackets, you all know how to use the table. Then I also have a g of x now, which is 2x. When the calculator asks me for g of x, I'm going to type out 2x. I'm going to press equals to, I'm starting at, let me start at 0, and I'm ending at, let me just go for 6. Step value, I'm stepping every one. The distance from each x value is 1. Yes, so let's see what we get. So obviously here, undefined, we know that's undefined there. Right. When it's this is 0, when it's 1, that's 0. This is 2. When it's 2, it's 1.3862. And this is 4. Are you following what I'm doing here? All I do is type it out, use the table function on all the Casio calculators, easy. When x is equal to 3, we got 1 comma 3, sorry, I'm wrong here, 2 comma 197, so it's 2 comma 1972. This is 6. When x is equal to 4, this is 2 comma 7725, and this is 8. When x is equal to 5, 3 comma 2188, and this is 10. When x is equal to 6, this is 3 comma 5835, and g of x is 12. Have you all got the same thing? Right. Okay. So now, why am I doing this now? I want to make sure that these two, I don't have a completely different picture here. All right. So I'm checking now which graph. You see, according to my sketch on the board here, the corresponding y values for my straight line are all, they are all, okay, let me just rephrase what I'm saying. The straight line is above the log graph. Okay, that means the corresponding y values of the straight line is always greater than the corresponding y values of the log graph. Now, that's just by a rough sketch. But now this is the true values here. Can you see that? So, let's see. I sketch my straight line. When x is equal to 1, y is equal to 0 there. Let me just check. When x is equal to 1, y is equal to 0, that is 4. Yeah, that is correct. When x is equal to 1, y is equal to 2. So this is always greater. That's 4 is greater than that, 6 is greater, 8 is greater, 10 is greater, 12 is greater. So this is the picture. This is the picture. This graph is only going up and up. This graph is slanting. Can you see that? Look at these values here. It doesn't jump from 2 to 10 or something. It goes 2.19, 2.77, 3.2, 3.5. It seems like it's going to carry on in a very slow incline. Can you see that? But the straight line definitely goes from 2, 4, 6, 8, 10, 12. It's multiples of 2. 14, 16, 18, 20. So therefore, there should not be any point of intersection between these two. And this is, we'll go with this sketch here. Alright. So, alright, so now, sketch the graphs, show the area, and what else do we need to do here now? The line-wise, show the representative strip that you would use to calculate the area. Now, how would you calculate the area? This one here. Okay. You be careful with this because if it's best to use a representative rectangle with a breadth of delta y. Okay. Because if you go up, your limit is 2, and you go down, it's 0, and you check what's touching the right, what's touching the left of this rectangle. So the right end is touching the red graph, which we did not label. This here is y is equal to ln x, and this is y is equal to just 2x. So let's call this one x1, let's call this one x2. It doesn't matter which one you call x1 or x2, but the fact is that the right end is touching the red graph, which is x1. The left end point is touching the blue graph, which is x2. So let's calculate this area now. Okay. So what's going to happen? I'm going to erase that table in a few seconds. But anyway, this is the sketch. This is 5.1.1. 5.1.2. Just read the question there to me. Calculates the area. Describe. Calculate the area described in 5.1.1. In question 5.1.1. Right. Now, I'm going to erase everything here. You already have that down. Okay. This is a table. We use this table to check if there's any possible points of intersection. This is not 100% guaranteed. You normally have to go and find points of intersection. But this one here, you will have to use Newton's method. That's another story. Okay. If you want to go and actually find out if there are any points of intersection. So that's 5.1.1. That's your 2 marks. Okay, 5.1.2. Calculate the area. Okay. Calculate the area. So we're going to go, you know that area is equal to length times breadth. So delta A, area of the representative rectangle, just that small rectangle there, is equal to the length. Now, the length is the longer side. So this is the length from x1 all the way to x2. So if I want the length, I'm going to subtract. I'm going to go x1 minus x2. You're clear with that? Because if I had a rectangle here, and this is 5, and this is 1, how will I work out the distance here? I will go 5 minus 1, which is 4. So that's why I'm going x1 minus x2. Can you see that? Times the breadth, which is delta y. Alright. Now total area. Once you put your total area, then you won't write down delta A, you just write down A now, and now your summation, you're integrating from A to B, x1 minus x2 dy. Okay, now we need our B and A and our x1 and x2. So B and A. So I decided to choose dy. So therefore, I need to know what is the end, the highest point. Here is 2 for the area. This is the area now. You can see the area here. Bounded by there and there and this line here. So this area is here. So it's starting at 0, ending at 2 there. You can see that clearly, the y values. So that is 0, 2, x1 minus x2. What is x1? Well, there comes a problem now. Okay, you need to make x1 the subject of the formula here. Right, so this N6 paper was not a simple one. They're making you work here too. So we know that y, remember what is x1? I said y is equal to 2 ln x1. So I need to make x1 the subject of the formula because I'm integrating with respect to y. So I'm going to go ln x1 is equal to y over 2. I'm just writing it on the left hand side. Divide by 2 there. Can you see that? Now, I just used the log. I just erased it now. If you have from there to there, what's your base here? E. So x1 is going to equal to e to the power y over 2. That is your x1. E to the power y over 2 minus x2. So we know that y is equal to 2x, 2. So therefore y over 2 is equal to, in fact it was nothing too difficult. It's just that if you forgot how to convert from logs to exponents, you're going to have a problem if you decide to choose this technique. This is not the only technique. So x2 is y over 2 dy, and then now the last part is easy here. We're just going to integrate and substitute. So you integrate e to the power half y, it's going to be e to the power half y, all divided by half. Minus 1 over 2, integrate y, that's going to be y squared all over 2. Substituting 2 and 0. If you want to simplify it, you can, but it's all unnecessary work. That means, like what I'm doing here now. This is all unnecessary. You can just go straight to your calculator and work it out. So I get 4, 4, 3, 6, 5, 6, 3, 6, 5. 5, 6, 3, 6, 5, 6, 3, 6, 5, 7. When I substitute 2, put a minus sign and now substitute 0 into everything, which is just 2. Right, so let me just double check. When I substitute 2, I get 4, that minus 2. You're going to get 2, 4, 3, 6, 5, 6, 3, 6, 5, 7 units squared. The reason why I am writing down all the decimal places is because when we do our next, because this is not the end of this, is just 5.1.2. We need to work out 5.1.3 and use this information. So the final answer here for this problem is 2,437 units squared. But when we use this solution, we will not use the rounded up value. we use as many decimal places as possible for the next part. Let's finish the next part there quickly, which is the second moment. Alright, so 5.1.3, calculate the area moment about the y-axis as well as the x-coordinate of the centroid of the area described in 5.1.1. So, I just redrew the area. So when you are dealing with centroid now, the centroid, center point of the whole area, we need to label it. Okay. So remember this was x1 here, and this part here is x2. So it's going to be x1 plus x2 over 2 and y. That's how we label the centroid. x1 plus x2 over 2 and y. Now, here, if I want to find out, let me just write it down here. The centroid, the coordinates x bar, y bar. Okay, so x is equal to my over a, and y is equal to mx over a. My means moment about the y-axis, and this is moment about the x-axis. Area is the denominator which we already worked out. So all we need to do is work out my and divide it, and we're done. Right. So delta my. This means moment about the y-axis. If you say y, it's moment about the y-axis. Right. This is given by the formula area. Okay. Now, area times. Now there are two formulas. Okay, let me just clear that up first. Right, so your second moment of area. Okay, second moment of area. Sorry, why am I saying second? Sorry, your centroid. Sorry, your centroid is, first of all, there is your representative rectangle there. Okay, so let's draw it here. This one was x1, x2, this is delta y. Okay, so now your moment. Okay, so the formula is area times the distance from the y-axis. Okay, that is your area moment. You're not second, I'm confusing with second, I'm only thinking second moment of area, but we're dealing with centroid. Second moment of area will be area times distance squared. First moment is just area times distance. Okay, now the diagram is very important here. So I'm just enlarging it for you. Okay, while we're on this here, if this was the situation, let's say we had a different problem, or let's say we chose delta x. Then this will be y1, that will be y2, So the centroid will be x y1 plus y2 over 2. But if it's delta y, then it's going to be x1 because you're getting the center point. It's going to be like the midpoint, x1 plus x2 all divided by 2. It's actually the midpoint. Okay, so this is the situation that we are dealing with at the moment. Now, what is area? What is area? Area is what we just worked out in the previous example. How did we work out area? It was x1 minus x2 times delta y. Right? That was the area. Length times breadth. The distance from the y-axis, let's go to the y-axis. Now, from the y-axis, you are measuring an x value. If I say from the x-axis, you are measuring up, you are measuring a y value. So, from the y-axis is the x coordinate here. Can you see that? That's it. So, from the y-axis, it's going to be x1 plus x2 all over 2. Okay. Now, what happens here is you got your 1 over 2 and x1 minus x2 times x1 plus x2 is the difference of two squares. So it's going to be x1 squared minus x2 squared delta y. Right, so this is how I remember it from words, and I look at the diagram and then I form it. Because if you just try and memorize it, you can if you memorize it. But you might get confused if the diagram, if you change, from delta y to delta x. So this is the way that I remember it. Okay. Now, total. So that's 1 over 2. We got b and a. x1 squared, x2 squared, dy. Okay. Now let's substitute. So that's going to be b and a, same b and, sorry, not b and a. Why am I going b and a? Normally we write b for x values is going to be d and c. Okay, but if you write b and a, it's just a constant, so it doesn't. The main thing is the y values are 2 and 0. There's my half there. x1, what is x1? x1 is half y. Squared minus x2 squared dy. Okay. Let me not erase here. So that is x1 squared, x2 squared. So this is going to equal to half, 2, 0. Okay, now, when you have a power raised to a higher power, what do you do to the two powers? You multiply the exponents. So that's e half y multiplied by 2 is 2 and 2 cancel. It's just, you're clear with that? It's just y. Minus, this is squaring now. So that's y squared and 2 squared is 4. dy. And now we can integrate this. Right, we can integrate it. So that's going to be, this is a 1, so that's going to be e to the power 1 y over 1. It's going to be minus y to 2 plus 1 will be 3 over 3 times 4, which is 12, substituting 2 and 0. Calculator. So let's do this one here. So that's going to be e to the, you'll double check on the calculator too there. That's e to the power x. I'm just using x there, minus 1 over 12. Calculates, and that will be 2, 6.7, 2, 2, 3, 8, 9, 4, 3, 2, minus, substitute 0, and I get 1. So I get 2, 8, 6, 1, 1, 9, 4, 7, 1, 6 units to the power 3. Why is it to the power 3? Because area is squared, distance is a unit. Unit squared times unit is units to the power 3. It's not the final answer. This is almost very close to the final. We just need to divide. So what did we work out now? We worked out my, the moment about the y-axis. What did we work out before? We worked out a. We're ready now to divide and get our final answer. You're clear with that? So therefore, x is going to equal to my over a. My is 2, 8, 6, 1, 1, 9, 4, 7, 1, 6. All divided by, what was that area? The area was 2, 4, 3, 6, 5, 6, 3, 5, 7. Okay, so now this is units to the power 3, and that's units squared. Moment is to the power 3, and area is squared. So let's divide it. That's divided by 2.43656357357, and we get 1,174 units. That is the x coordinate of the centroid, and we will continue tomorrow with the rest of the paper.